This video includes step-by-step visual instructions of how to model the dehydration synthesis reaction of a triglyceride molecule, understanding what elements make up lipids, and the variation in structure of different classes of lipids, and classifying the types of bonds forming the resulting triglyceride molecule will be important later in understanding the functions of these molecules in living organisms. To actively participate in this modeling activity, print the paper pieces and cut them out as shown in the following slides and practice explaining the process of dehydration synthesis. Lipids are technically not true polymers. Lipids share the property of being nonpolar and hydrophobic. They have the elements carbon, hydrogen, and oxygen like carbs, but they have a lot less oxygen, which is what gives them their hydrophobic properties. We will only be modeling one of the three types of lipids. The triglyceride is composed of a glycerol backbone and 3 fatty acid chains, are large molecules assembled from smaller molecules by dehydration synthesis reactions. When the dehydration synthesis reaction occurs, one water molecule is removed for each fatty acid joined to the glycerol. So, in total, there will be 3 water molecules formed in the dehydration synthesis reaction of a triglyceride. The functional groups that are involved are the hydroxyl groups on both the glycerol backbone and the fatty acid. The resulting bond that will form is called an ester linkage. On the pieces, cut along the dotted lines to produce your water molecules and show the formation of the 3 ester linkages. This molecule is a saturated fat. There are single bonds that make up the fatty acid chain, and as many hydrogen atoms are bonded to the carbon skeleton as possible. This allows the molecules to be tightly packed together, forming a solid at room temperature. You also need to model an unsaturated fat. The difference between the saturated and unsaturated fats relates to the presence of a double bond and fewer hydrogens in the fatty acid. This double bond prevents the atoms in the molecule from tightly packing together, resulting in the property of being a liquid at room temperature. In summary, the purpose of modeling these processes is to understand the elements present in lipids and how dehydration synthesis reactions form ester linkages. In addition, it's important to understand the structural differences between unsaturated and saturated fats and how this affects the properties of these lipids. This is Ms. Wilson speaking, reminding you to have a golden day, and I hope you are able to retrieve some helpful information from this video.